All right, so as you can see in lesson 46 up there, we're going to deal with complex roots, and then we're going to factor over complex numbers, okay? So basically these two are the reversals of each other. So this time with this one, we're going to start with the answers. Remember, that's what the roots are. That's what x equals, and then we're going to come up with the equation for it. Later on, we're going to have the equation, and then you have to come up with either the factors or the answers for that one. All right, so as this says up here, write the quadratic equation with a leading coefficient of 1. Okay, most of the time we don't have to worry about this a whole lot because it'll take care of itself, but do pay attention to that. Whose roots are 1 plus 2i and 1 minus 2i. So what the roots are, that tells us what the x-intercepts are. All right, so first thing we're going to do is we're going to set x equal to each one of those. And then once we have our answers, we need to get the factors from those. So to get the factor, we have to set this equation equal to 0. So we got to get a 0 on the right side. So we're going to have to subtract the 1 over and subtract the 2i over. So x minus 1 minus 2i is the first factor. For the other one, we're going to subtract 1 and add 2i over to get it set equal 0. Once we have them set equal to 0, then that tells us that these are our two factors here. So we are going to have to multiply these two together to be able to come up with our equation. So big, huge distributive property problem at this point. So we're going to have to take x times all three of these. So we've got x squared minus x plus 2ix. Then we're going to have to take a -1 times all three of these. So -1 times x is -x. I kind of stack mine to keep my like terms together. You can do it however you want though. -1 times -1 is a +1. And then -1 times 2i is a -2i. Then we've got to take a -2i times all three of these. So we've got a -2ix. Then we'd have a +2i. And then for this last one, we have -2i times +2i. That'd be a -4i squared. I squared's a -1, so that would turn into a +4. All right, now when you combine your like terms here, one thing that will always happen, your imaginary terms will cancel each other out. So both the 2ix's and the 2i's are going to cancel each other out. And what we're left with is x squared minus 2x plus 5. All right. And then that looks very much like what we would normally start with one of these problems. Now, did we fully solve this problem based on what the directions are asking us to? Do we have a leading coefficient of 1? Do we have a leading coefficient of 1? Yes, we do. Okay. Did we fully answer the question though? What's wrong with it? Right, we need to have, first of all, it is a quadratic, right, because it's an x squared, but it is not an equation yet. Right now, it's an expression. So you can either set it equal 0, set it equal to y, either one works, doesn't matter which one, okay? Most of the time, I think the answer key is going to say equals 0 down here. All right, and then that is our quadratic equation where we would get the answers 1 plus 2i and 1 minus 2i. All right, questions there at all? Okay, next page. All right, we need to factor 2x squared plus 4x plus 8. All right, first step to factoring is always to do what? Yep, pull out whatever we can. Can we pull something out? We can pull a 2 out. x squared plus 2x plus 4. All right. Now from there, hopefully, if we can, we're going to have two sets of parentheses, right? So it's an x and an x. The second sign means they're going to be the same. The first sign means that's what they are. So it's going to multiply together to give you a 4, but add together to give us a 2. Absolutely nothing. All right. So before today, we couldn't go any further with that. Okay. When you were told how to factor the very first time, all right, you were told, all right, there are some of these that you just can't do until today. After today, you're going to be able to factor absolutely everything. Okay. Now, how we do that is, well, if you can't factor it and you're trying to solve for what x equals, what did we say would always work? Quadratic formula. So we're going to use the quadratic formula for this. Remember, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, our a value is in front of our x squared. Our b value is in front of our x, and our c value is the number added or subtracted onto the end. Okay, now we are only going to deal with what's inside the parentheses here. We already took this 2 out. All right, so our a value is 1, b value is 2, c value is 4. We just start plugging that into the equation and start simplifying this down as much as we can here. All right, so underneath the square root sign, I get a negative 12. All right, once we have now, can you simplify the square root of negative 12? What's the first thing you have to do? Yep, you take out the I, right? So this turns into negative 2 plus or minus I square root of 12 over 2. And then this 12, we can simplify down. This would be a 4 and a 3, and a 2 and a 2. So this, because we have a pair of 2's here, this would simplify to negative 2 plus or minus 2i times the square root of 3 all over 2. All right, now can we simplify that? Is there anything we can pull out of the top to simplify with the bottom? We can take a 2 out. Now, please do not just cross things off here. All right, this whole top is an expression. All right, you have to factor out a 2 out of the top. So we're left with negative 1 plus or minus I square root of 3. And that is all over 2. And then those 2's can cancel. All right, so what that tells us is x equals negative 1 plus I square root of 3, and x equals negative 1 minus I square root of 3. Those are what the answers would be if we were solving this. But this one asks us to find the factors. So we just have to set each one of these equal to 0. So we're going to add the 1 over, and we're going to subtract the I square root of 3 to get it set equal to 0 then. And the same thing for the other one. We're going to add the 1 and add I square root of 3 to get it equal to 0. And once it's set equal to 0, what that means is these are both our factors of our original problem here. All right, so we would have x plus 1 minus I square root of 3 is our first factor, and x plus 1 plus I square root of 3 as our second factor. All right. Yeah. Am I missing something though? You see anything that I'm missing? What was our very first step that we did? We pulled out the 2, right? Do not, if you pull this out, you've got to make sure that we bring it with. So we've got to have a 2 come down in front of this. And this would be completely factored here. All right. Max, you're not working on homework while I'm teaching, are you? You're not working on that other stuff. Because if you are, then I'd have to rip it up based on stuff I've done in the past, right? Yeah, that's what I thought. All right, any questions here? Lots of steps to it, but to be honest, it's all these steps that we've done before. Okay, we're just being asked to do a different sort of problem here. All right, so go ahead and do this one. Kayla, you can do it. You do all the same steps we just did. Is that what you got so far? Okay. Now, you can't break down the square root of 85, so you just got to leave it. Okay. The only thing that I would tell you to do is it'll be a little bit easier to do the math when you go 5, 6 plus square root of 85 over 6 and 5, 6 minus square root of 85 over 6. All right. So then that's what x equals, right? So then we just got to get the factors from there. So we set this first one equal to 0. We're going to have to subtract over the 5, 6 and subtract the square root of 85 over 6. And that's the first factor. The second one, we'd have to subtract over the 5, 6 again. But then we're going to add the square root of 85 over 6. And there's our two factors. Think about this answer, though. Does this answer make sense? What could you always do to check to see if you got this right? You could graph it. I don't know why anybody would do that, Connor. But yes, you could graph it. Okay, you're not wrong. All right, what else could you do? Yeah, you could foil it back together. Now the problem would be, though, is if I start to FOIL this, isn't x times x, x squared? It's supposed to say a 3x squared. It's not a no solution. Okay, here's the deal with this, all right? With these, okay, if you were to have a multiple of this, say, for example, you had instead of 3x squared, say you had 6x squared minus 10x minus 10, you would get the exact same factors, okay? This top one is just a multiple of the bottom one, okay? This answer, when you FOIL it back together, you would actually get an x squared minus 5/3 x minus 5/3. Okay, they're just multiples of each other. Okay, so this is still a factor of the original, even though it looks like we're not going to get a 3x squared there. We actually do. Okay, so, all right. Any questions? All right, so when it says to factor, you got to figure out what x is going to be equal to for this. You got to throw it into quadratic formula more often than not to get your answers. And then from your answers, you get your factors. All right, and that's it for 46. Going on to 47. If you need graph paper, go get graph paper. Vertical translations of, those are called sinusoids, okay? Those are just all trig functions are called sinusoids. And then we're going to do a little arctangent at the end here. All done? Okay, thank you, man. All right, now the same rules that we talked about the first time through will apply to all of this stuff. All right, I still only need to see 360 degrees of your graph. Okay, and if you want to put more than one on the same graph, that's fine. Just tell me which one you're doing. Okay, I'm going to do the blue one. I'm going to do blue for y equals sine x, and then I'll do red for our second one. All right, so help me out. Sine of x, where do we start at for sine? 0. Where do we end at? 0. Right, so we've got those 2 points. At 180, where are we at? We're at 0. Halfway in between, always for sine, is at 0. At 90 degrees, where are we going to be at then? How do we know that it's a 1? Yeah, there's no a value. When there's no a value here, that means that it's a 1. So we're going to be up at 1 here. All right, and then for 270, we'll be down at 1. All right, and there's our graph. All right, so there's our y equals sine of x. Any questions on that one? All right, going to our second one. What does this mean? What's going to happen to our graph because of that plus 42? What's that, Max? We're going to go up 42. This is the best graph ever, okay? As far as all the graphing you have ever done, this is the easiest one ever, okay? What we're going to do, I'm not going to go up 42. We're going to be up towards the ceiling somewhere if I went up 42. Okay, instead, what I'm going to do is I'm going to get rid of this one, actually. Okay, and then what I'm going to do is say, normally our x-axis is when y equals 0, right? Instead of making it a 0, I'm going to make it a 42. So that means our starting point is at 0. Our ending point, I'm sorry, not at 0. Our starting point's at 42. Our ending point's 42. At 180, it's also at 42. At 90, it will be up at 43. At 270, it'll be down at 41. And then we see the exact same graph, don't we? It's just shifted up 42 units there. Okay? When you graph these out, go ahead and use this shortcut. It's totally fine. Okay? Now, do make sure though, what you do is when it's just this blue one here, okay, I'm going to be able to tell, yep, you went up 1. All right, because that's just assumed. When we're going up 42, you're going to have to label all 3 of these here. Okay, do make sure that you put your lower one on the bottom. Okay, I have had these switched before. I'm going to be mean and take points off then. All right, so 43 on the top, 41 on the bottom. All right, any questions there? All right, so let's graph this thing out. And this is one that we're going to see most often in your homework when they start putting everything together here. So we got a graph y equals -12 minus 3 sine of x. All right, now I'm not going to graph the whole thing all at once. Okay, I break this into parts. It's just like when you're doing an algebra problem. We have to do step by step by step. All right, so how we start is I'm going to deal with this -3 sine of x first. All right, so what that means there is we're graphing out sine. Sine, we know, starts at 0, ends at 0. Halfway in between is going to be at 0. But at 90, we're going to be at where? We're going to be at -3. And that means at 270, we'll be at +3. And we get some kind of graph like that. All right, so there's your first step, is dealing with just the sine part of the function. We went down to -3 because it's a negative out in front of it. Okay, and then we just got to deal with whatever's left over here. What's this -12 mean? We're going to go down 12. So instead of pushing this down 12, we're just going to rename our x-axis as -12. All right, which means our highest value is not at 3, it's going to be at what here? -9, because we're getting bigger by 3. And then our lowest value would be -15. All right, so there's our sine graph with it completely labeled, and that's all we got to do. All right, so this plus or minus thing, in our book, for whatever reason, they put it first. They put it before the sine function, so just be aware of that. That's why I wrote it this way. Okay, but you would also see it like this. Okay, whenever there are no parentheses there, that means it's a vertical shift. So how much you're going up or down. Okay, it could be at the end, like here, or it could be at the beginning, like this one is here. All right. Questions on graphing these vertical translations here? All right, one more graph. Last graph of the day. So once again, we're going to break this into parts here. We're going to leave the 20 until the end. We're just going to deal with the negative x, or a negative 8 cosine of x here. All right, so cosine rules. Where do we start at? We start at whatever number, or yeah, whatever number is out in front. So we're going to start at negative 8. So right away, I'm going to call this negative 8 here. Okay, wherever we start at, we're also going to end at. Halfway in between, at 180, we're going to be at what? We're going to be at positive 8. And then at 90 and 270, we will be at 0. All right, so do the best you can to draw in that curve. All right. So if the question was y equals negative 8 cosine of x, that's what our graph would look like there. All right. From there, we've just got to shift it up 20. So that means our highest point is not at 8 anymore, is it? It's at what? It's at 28. We're just going to add 820 to that. So this value is going to be at 28. Our middle value is going to be where? 20. And then our lowest value is going to be at 12. There it is. Okay. All right. Any questions on shifting up or down? We're going to shift right and left later on. I know. It is a little bit harder. Something like that. Yeah. All right. These. One more problem here. We need to evaluate sine of arctangent of 1 over the square root of 3. All right, that is right, Max. First step is to graph it out. All right, so now remember for this, whenever you see an arc, what that means is tangent inverse. Those mean the exact same thing. If there was no sine here at all, and you're just trying to find tangent inverse of this, you are always looking for some kind of degree measurement. So you're looking for the angle measurement. If, say, this arctan was not here, and you would have just sine of an angle measurement, you are always looking for the ratio of the sides, okay? Now for this, they're just put together here. So we're going to have to do both of them. All right, so arctangent, so we're trying to figure out when tangent inverse is 1 over the square root of 3. Well, what quadrant would that be in? It'd be in the first one. Because what this says, tangent is opposite over adjacent. Both of those are positive here. So we'd have a 1 here, a square root of 3. When we have those two side lengths, what is our hypotenuse? 2. All right, now from there, we drew out the triangle for tangent inverse. Okay, we could figure out the angle measurement, but we don't have to here. Because what we want to do is we want to find sine of this triangle. You guys know that sine is opposite over hypotenuse. So the answer is 1/2. right? But how many triangles do we always have for this? Yeah, we're going to have 2 of them. The other one for this one. Now, if I put negatives into both the top and the bottom for this, that would simplify down to 1 over the square root of 3, wouldn't it? If these are both negatives, what quadrants would that be in? That'd be in 3. Tangent always flips. So this would be a -1. This would be a negative square root of 3. And your hypotenuse is always positive, so that's a 2. What would our answer be for sine of this triangle? It'd be a -1/2, right? So our 2 answers here would be a positive and negative 1/2 here. Okay? Yeah. No, hypotenuse for any of these triangles always stays positive. Okay? All right. Any questions for me? All right. I am done with you guys. Homework. Any 25 questions from lesson 46 and 47? All right, we will not have a quiz over this, so you can pick any 25 you want because we have a test that day. So do make sure that you start studying for that. For some of you, your grade will depend a lot on how this test goes, right? Your letter grade part of it. Okay, lots of you are right on the line between 2 letter grades. So do the extra work to get the higher letter grade right now. All right. Do remember on Tuesday though, I know I don't have it on the board, but I will. You guys have a quiz over lesson 44. Okay, I'll put that up there right now. All right, questions for me? Yes, Hope. Will we get our test back today?